The argument from design is not a new argument. It's actually a quite old argument and goes back at least as far as a rather classical treatment of this whole argument that was first developed by a fellow named Paley in the early 1800s. Piling detail upon detail, Paley described in intricate detail many different adaptations found in living things, and then made the analogy between living things and a watch. Obviously, a watch requires a watchmaker, and the very, very amazing adaptation of living things to their environment, in his mind, clearly suggested some kind of an intelligent designer. About 60 years later, Darwin came along, wrote his Origin of Species, and was able to explain not all, but at least many of these adaptations through natural selection, discrediting much of Paley's argument. From 1859 until about 1960, that's pretty much where the matter lay. In the first half of the 20th century, I think it was widely believed by many people who work in the field of science that we would ultimately explain everything that we see in the natural world in terms of chemistry and physics alone, rendering belief in God not impossible, but simply superfluous or unnecessary. However, beginning in 1960 and continuing on through the remaining part of the 20th century, a remarkable thing occurred. Many, many new discoveries in many diverse fields of science began to change the way many scientists saw the situation, and many became more and more persuaded that maybe chemistry and physics isn't ultimately going to explain everything that we see after all. There have been a lot of different articles published in newspapers, magazines, and books over the last 40 years that illustrate this change, which I think has been gradual, but over time cumulatively very dramatic in the way scientists think. There was a major conference held in Washington, D.C. in 1988 that brought together scientists from around the world to consider this very question, the character of the universe. Does it appear to be designed, or can we ultimately explain everything that we see in terms of natural laws alone? A reporter from the Washington Post, in summarizing a rather nicely done article that she wrote about the conference, concluded with the following comment about the impression she had talking to many of the attendees. Many scientists who not long ago were certain that the universe was created or peopled by accident are having second thoughts and concede the possibility that some intelligent creative force may in fact have been necessary. This has really gotten to be more mainstream media in the last 10 years. In particular, in 1992, a cover article in Time magazine was entitled, What Does Science Tell Us About God? At about the same time, Discovery magazine had an article, Discovery magazine had a cover article entitled 10 Great Unanswered Questions of Science, 3 of which are very germane to our topic for this evening. And more recently, Newsweek magazine in 1998 had a major article discussing this whole business. Is what we're learning in science pointing to the idea of some kind of an intelligent creator? Now, there have been a whole host of books that have been published in the last 15 years as well. One important one that I inadvertently left off, The Design Inference by Bill Dembski, but a whole host of books written by people, many of whom are not necessarily people of faith, and published in many cases by major publishing houses such as Cambridge or Oxford, have appeared and I think have dramatically influenced at a popular level the thinking of many people who are interested in this particular topic. Certainly most scientists, I think, are aware of this trend. Now, I don't want to pretend that all of the people who are working in the field of science and all the people who write books are in agreement. Obviously, there's some major detractors with regard to this whole thesis that I'm going to be discussing this evening, probably the most well-known of which is Richard Dawkins, a well-known atheist who happens to be a biologist at Oxford University. And he's written a series of books, the most recent of which isn't on my slide, but probably 2 of the best-known, The Blind Watchmaker, Why the Evidence of Evolution Reveals a Universe Without Design, and Climbing Mount Improbable. In both of these books, Dawkins is quite willing to admit that there are many things in nature that appear to be designed. But he would argue that while they appear to be designed, if we look carefully enough into the whole nature of these different phenomena and the artifacts that might appear to be designed, we'll ultimately find some kind of a very natural explanation. He actually defines in his most recent book, Climbing Mount Improbable, second most recent, a term which I think is useful for our discussion this evening, and the term he introduces is the term designoid. Now, he defines a designoid as basically an object or a characteristic of the natural world which appears to be designed but can be explained naturalistically. And then he gives some nice examples of what a designoid might actually look like. So let's have a look at what these might be. At the beginning of his book, he gives a very nice example of a rock formation in Hawaii which, viewed from the right angle, at the right time of day, at the right season of the year, casts a shadow that looks reminiscent of a well-known American president. Now, for those of you that, it's not this shadow, forget that. It's this one here. And if you look, there looks to be some hair, a nose, some lips, and it in fact does have a great resemblance to an American president. Can you decide which one? Yeah, JFK. Some of you are too young to know what JFK looked like, but for those of us that are in my age group, it's a pretty familiar silhouette, distinctive profile. Now, one might think that somebody has actually gone over and carved on this rock to give it this appearance, this shadow silhouette of JFK. But in fact, if you go look at the rock, you'll find it certainly isn't the case. There's not one bit of evidence that this rock has ever been altered in any way by any kind of human beings. It's quite clear that although this appears to be a highly improbable occurrence, it is in fact an artifact of nature that can be explained as nothing more than a coincidence. Now, even Dawkins would admit that what we see here is not a designoid. This is not what wind, rain, sleet, and hail normally makes. If you look at this, it's quite clear that we see four faces, any time of the day, any season of the year, viewed from any angle. We see full face, not silhouette profiles of Washington, Jefferson, Roosevelt, and Lincoln. And this would clearly be an example of design, much the same way the previous example would be an example of designoid. Now let's do a short exam here and see how you're tracking on this. Here's a third example. This is an aerial photograph of a high desert in China, in which we see what appear to be several examples of pyramids. And the pyramids are aligned in such a way that they seem to be calling attention to another rock formation, which appears to be a face. In fact, if we look more carefully, this is what it looks like. Now, my question to you is, what is this, design or designoid? Design or designoid? Now, I'm going to give you a little bit more information, which will almost surely change your opinion. And the additional information is that I fibbed about the location, okay? This is not in a high desert in China. This is actually aerial photographs from Mars. Now, if I tell you it's on the first face of Mars, does it change your opinion? It certainly does mine, because I might have thought it possibly could be the result of some ancient Indian tribe in China. On the other hand, as soon as I realized this is on the face of Mars, the burden of proof just got much, much greater. Why? Because I don't think there is intelligent life on Mars, and therefore convincing me that this is the result of intelligent life is going to be a much, much harder sell. Now, the reason I share this example is that I think all of us come to a topic such as our one for this evening with some preconceived ideas. And our preconceived ideas will often cause us to see exactly the same set of data with very, very different interpretations. What I'd like to encourage you to try to do for the evening is to set aside whatever preconceived ideas you might have as you've come to the program this evening and simply let the data speak for itself. And at the end of the evening, to draw your own conclusion about whether, in fact, our universe, taken as a whole, can be better explained or interpreted as being the result of some kind of intelligent design, or whether it is, in fact, appropriately nothing more than, as Dawkins would say, designoid. My purpose, then, for the evening is to consider whether the character of the universe suggests an intelligent cause, and this depends on at least three things that we'll discuss this evening. Did the universe eternally exist, or did it begin? Are all appearances of design in nature, in the nature and character of the universe, ultimately found to be explained naturalistically, or can they be explained naturalistically? And is the origin and development of life explained entirely in terms of natural processes? Now, for sake of time, we're not going to get into this third topic, though I think it's a very important one, and I'll mention it just briefly toward the end of the program. Let me emphasize at the outset, one cannot scientifically prove or disprove the existence of God. However, I think it's fair to say, let's look at the universe and see what it suggests. Does it seem to be more likely to be the kind of a universe that could have just happened on its own, or does it appear to be one that seems to require something more than just chemistry and physics and maybe some good fortune along the way to account for what we see? Is indeed it designed, or is it simply a designoid, something that looks designed but in fact is not? Now let's begin with evidence from the Big Bang. Most of you are familiar with the Big Bang, so I won't review the story except to say that it's widely believed by many people in cosmology today that the universe is expanding, much like dots on the surface of a balloon. If you look from any given dot, all the rest of the dots are moving away from that particular location, much as they would on the surface of a balloon as it's expanded. And that's exactly what we see as we look out into the universe today. No matter which direction we look, things are moving away from our particular vantage point. And the explanation, with a lot of corroborating astronomical data, suggests this picture of this expanding universe. Now, if we run the picture backwards, obviously at some point in time, all of the matter and energy in the universe would have been at one place at one point in time. And the basic idea of the Big Bang is that the universe was born in this fiery explosion, for which we're now seeing the outcome at a much later period in time, maybe 10 to 12 billion years. Now, with regard to the Big Bang, let me simply begin with a little bit of philosophy. A universe that is eternally existed is much more compatible with atheism. A universe of finite duration is much more compatible with deism or theism. To illustrate this, let me share with you several quotations. Sir Arthur Eddington says, philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole. Well, why is it repugnant? Because Eddington would prefer a universe that eternally existed as a person who happens to be an atheist. John Gribben, writing in Nature, says it very graphically: the biggest problem with the Big Bang theory of the origin of the universe is philosophical, perhaps even theological. What was there before the bang? This problem alone was sufficient to give a great impetus to the steady-state theory of the universe, but that theory is now sadly in conflict with the observations. Stephen Hawking, in his book A Brief History of Time, notes, so long as the universe had a beginning, we could suppose that it had a creator. Well, Robert Jastrow, a well-known astronomer from Columbia University, first director of the Goddard Space Center, and a highly regarded scientist, was invited to give a keynote address to the American Association for the Advancement of Science in 1977. And in that address, he surprised his scientific colleagues, about 1,000 of whom were in the audience, when he basically gave a talk entitled God and the Astronomers. And let me emphasize, by Jastrow's own indication, he was then and is today basically an agnostic. This particular address was subsequently published by the same title by the W.W. Norton Company, and I think it's still available today as a paperback book. Now, in this particular presentation, Jastrow makes several key points, the first of which is from 1929 to 1969, evidence for the Big Bang cosmology was actually much more compelling than evidence for the alternative cosmologies of that time. Yet many scientists were unwilling to accept the Big Bang cosmology because they did not like the philosophical implications. With the discovery of the background radiation in 1965, in fact, almost all cosmologists and astronomers came around and accepted the Big Bang as probably the most likely story of how the universe began. He makes the point that scientists like to put themselves above allowing their metaphysics or their presuppositions to influence their science, yet here indeed was an excellent example of where metaphysical assumptions were in fact driving, or in this case impeding, the progress of science. The second point that he makes, which is I think equally interesting, is best summarized by the concluding paragraph in his presentation and in the book, and it goes like this. For the scientist who has lived by his faith in the power of reason, the story of the Big Bang ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. As he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. Well, Jastrow's basic point is that scientists never started their studies with the expectation that the data would ultimately lead them toward belief in some kind of a creator. Rather, they had every expectation that the more we learn through science, the more we will render belief in God quite unnecessary. And yet, much to their surprise, at least in this area of cosmology, in fact, what they found pushed them toward rather than away from this idea of belief in some kind of a creator. Jastrow, in a subsequent interview, says astronomers now find that they have painted themselves into a corner because they have proven, by their own methods, that the world began abruptly in an act of creation to which you can trace every star, every planet, and every living thing in this cosmos and on the Earth. And they have found that all of this happened as a product of forces they cannot hope to discover. Well, what's happened since 1977? Has the story gotten better or worse? Between 1990 and 1992, there were a whole series of rather dramatic experimental observations, basically with two new instrumentations that became available. The Hubble telescope, which I'm sure you've heard of, a billion-dollar telescope that was shot into space and allows one to view the universe without the distortion that comes as light passes through our own atmosphere. And with the very enhanced observational powers that provided, four important predictions of the Big Bang have in fact been confirmed: deuterium abundance, boron and beryllium on elder stars, gravitational lensing, and a much more precise expansion rate measurement have all been very, very consistent with what one would predict with the Big Bang model. At about the same time, something called the Cosmic Background Explorer, COBE, was sending back to Earth all kinds of interesting measurements about the background radiation. And the most important of these, which were publicized first in 1990, the amazing smoothness of this background radiation, and then in 1992, the needed 1 part in 100,000 variation to allow the condensation of various kinds of stars and so forth, precisely match the fluctuations predicted in exotic Big Bang models. Well, the astronomical community and the cosmologists were ecstatic about these observations, so nicely fitting what had in fact been predicted by theory. George Smoot's a professor at the University of California at Berkeley, who is director of that part of the COBE project, says what we have found is evidence for the birth of the universe. It's like looking at God. This was published in many different newspapers, April 24th of 1992, when something which very seldom happens, science news was front page headlines on almost every major newspaper in the country with the publication of these results. Stephen Hawking at Cambridge University says it's the discovery of the century, if not all time. Carlos Frank at Durban University in South Africa said it's the most exciting thing that has happened in my life as a cosmologist. Professor Turner from the University of Chicago, unbelievably important. The significance of this cannot be overstated. They have found the holy grail of cosmology. Well, let's summarize what we can say based on the Big Bang as follows. From 1929 to 65, the steady-state hypothesis was favored for philosophical reasons. Basically, it supported atheism. With the discovery of background radiation in 1965, it persuaded most cosmologists to accept the Big Bang. And then I think discoveries by Hubble and COBE and more recent discoveries have provided overwhelming support for Big Bang cosmology, which, as I said a few minutes ago, is much more consistent with a theistic worldview. Now, let's look next at modern arguments from design. As I mentioned at the beginning of my talk, the early arguments that were made by Paley were in many cases, not all cases, but in many cases, undermined or discredited by Darwin's Origin of Species. But in the last 40 years, a new and I think much more potent design argument, in fact, has come into play as we've noted the many different observations about our universe that seem enigmatic and difficult to explain based on chemistry and physics alone. What I'd like to do is to look at three of these very specifically: the mathematical form that nature takes, the fact that the universal constants are just so, and the highly specific initial conditions. Now, there's a third kind of an argument, which again we won't get into tonight except to mention in a couple of slides, the origin of life, which itself I think comes under highly specific initial conditions. So we'll have to pass on that this evening. To help everybody understand what we mean by design, I want to give a very simple illustration, which I hope most of you can follow, even if you're not science majors. If you even had a high school science course, you can probably follow. Several years ago, we took our son and daughter to Italy on a business trip that I was on, and while we were there, we had the opportunity to go up the Leaning Tower of Pisa. One of the natural things that my teenage son wanted to do for his teenage daughter was to drop a water balloon on her head as she was down on the plaza walking around. And to try to do this, He knew he would get only one try because as soon as she realized he was throwing water balloons off the leaning tower toward her, there would be no second chance. So he needed to get this right on the first try. Now, as a high school physics student, he understood some things that he needed to know about this. You can actually take Newtonian dynamics or mechanics and write an equation for the height of the water balloon as a function of time, and it includes the height of the leaning tower of Pisa, the gravity force constant, the mass of the Earth, the time from release squared divided by 2 times the radius of the Earth squared, minus the initial velocity with which he throws this times the time from release. If we wanted to subdivide these, they actually illustrate the different components of design that I mentioned in the preceding slide. The mathematical form that nature takes is going to be very important in whether a given design can be made functional for the particular purpose at hand. The analysis always includes not just mathematical form, but universal constants. These are simply things that we measured, things like the gravity force constant, for example. And then the solution to this equation with this universal constant always requires assigning values for initial conditions. In this case, the height of the tower, the initial velocity. Now, if I take the mathematical form that nature takes, put in the appropriate value for the universal constant, insert the height of the tower, knowing what time it will take my daughter to get to the location underneath the leaning tower, my son can then calculate with what velocity he needs to throw his balloon so the balloon arrives at exactly the same time as my daughter. Now, in general, when we're doing engineering design work, we don't have the luxury of changing the mathematical form that nature takes, and we certainly can't change the universal constants. When engineers are doing design work, all they're doing is assigning initial conditions or boundary conditions to try to get a purposeful outcome in some particular application of interest. Let's look at each of these three in turn to see whether indeed the universe appears to have some design as an intrinsic part of its essential character. If we look at two famous early astronomers, Kepler and Galileo, Jonas Kepler, in doing his astronomy and his mathematical analysis of astronomical data, more specifically, notes the chief aim of all investigations of the external world should be to discover the rational order and harmony which has been imposed by God and which he reveals to us in the language of mathematics. Galileo, often thought to be somehow hostile to the Bible and to religion, was in fact not hostile at all. He was hostile to the incorporation of really the science of Aristotle into the dogma of the Catholic Church of his time. But in commenting on his own work, he says the laws of nature are written by the hand of God in the language of mathematics. If we combine their writings with the writings of two other famous scientists of the time, Newton and Copernicus, probably these four are sort of the all-star cast of scientists who, at the beginning of the modern scientific revolution, were key players. And taking their writings as a group, they believed that the universe was orderly and thus described by mathematics because God fashioned it that way. They also felt that God designed the universe and it was to be expected that all phenomena of nature would follow one master plan. One mind designing a universe would almost surely have employed one set of principles to govern all related phenomena. So early scientists saw the mathematical character of the universe as the natural and expected result of some kind of an intelligent creator. They would have been surprised, however, to discover that the many incredibly diverse observations we see in nature today ultimately can be described at a fundamental level by a small number of fundamental laws that can be couched in such simple and elegant mathematical form that they can all be written on one side of one sheet of paper. Newtonian mechanics written as Hamilton's equations, electrodynamics, electricity and magnetism, or Maxwell's equations, statistical mechanics, or Boltzmann's equations, the second law of thermodynamics, quantum mechanics, or Schrodinger's equations, and finally Einstein's general theory of relativity. These are the fundamental laws of nature, and interestingly enough, the incredibly diverse observations that we see around us all ultimately find their fundamental grounding in these 5 fundamental laws, so simple in mathematical form they can be written on one side of one sheet of paper. Now, occasionally I'll have a bright engineering student that says, well, you should see the equations we work with in my engineering class. They're a big mess. The problem is not the fundamental laws of nature. The problem is the boundary conditions. If you choose complicated boundary conditions, then the solution of these equations will, in fact, in some cases, be quite complicated in form or maybe even numerical. There are a few additional relationships, not truly fundamental laws, but important relationships in nature that are summarized here. But again, the point's still the same. The universe assumes a remarkably simple and elegant mathematical form. Well, what do modern scientists have to say about this? It's kind of interesting. Eugene Wigner, in a very, very well-known paper published in 1960 in a technical journal, The Unreasonable Effectiveness of Mathematics and Physical Sciences, puts it this way. The enormous usefulness of mathematics is something bordering on the mysterious. There's no rational explanation for it. The miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. Albert Einstein, in some letters published in 1956, let me emphasize the letters were published in 56. Somebody pointed out to me something which I already knew in a recent talk. Einstein died in 1955. These are not letters from the grave, okay? These were written just before his death and published after his death in a book. In his writing to a friend, he made the following comment with regard to this interesting observation about nature. You may find it strange that I consider the comprehensibility of the world to the degree that we may speak of comprehensibility as a miracle or an eternal mystery. The kind of order created, for example, by Newton's theory of gravity is of quite a different kind. Even if the axioms of the theory are posited by a human being, the success of such an enterprise presupposes an order in the objective world of a high degree which one has no a priori right to expect. That miracle, which grows increasingly persuasive, that is the miracle which grows increasingly persuasive with the increasing development of knowledge. Alexander Polyakov, a Russian physicist, was quoted in 1986, and there are many other examples we could point to. We know that nature is described by the best of all possible mathematics because God created it. Paul Davies, in his book Superforce in 1984, says, the equations of physics have in them incredible simplicity, elegance, and beauty. That in itself is sufficient to prove to me that there must be a God who is responsible for these laws and responsible for the universe. It's not enough that the universe assume a mathematical form, because there are many different mathematical forms that would still not provide a universe suitable to support life. In addition to the mathematical form, there are certain particular forms that are very advantageous and in some cases absolutely essential. Newtonian mechanics from Hamilton's equations will only give stable orbits, and that's essential. We need a place like our planet Earth to circle a place where we have an energy source like the sun, and that orbit needs to be stable over very long periods of time. We can only get these kinds of stable orbits if gravity is a function of 1 over r squared, which it is in a 3D universe, which our universe happens to be. Schrodinger's equations give stable bounded energy levels, which means stable chemical compounds, only for 3D or less universe. Maxwell's equations are only valid for a 3D universe, and high-fidelity transmission of light and sound is optimized in a 3D universe. So not only do we have a universe that assumes a simple, elegant mathematical form, but it also assumes the very specific form that seems essential to provide places of habitation, to provide chemical elements that have stability and can form stable compounds, each of these necessary requirements for a life of any imaginable type. Well, let's summarize then what we've said with regard to mathematical form, that our universe assumes a simple, elegant mathematical form that allows for stable planetary orbits, stable atomic structure, optimal wave transmission, and many other features is problematic from a naturalistic or materialistic worldview. Design would seem to be the more reasonable inference. A third requirement, beyond a universe that began, a universe that assumes a simple, elegant, and appropriate mathematical form, has to do with the universal constants. Now, it's quite possible to have a universe in which we have the right mathematical form, simple, elegant mathematical form that we mentioned, and yet have universal constants that still do not allow us to meet what are necessary requirements, not for life as we know it, but for life of any imaginable type. What kind of requirements might these be? Well, they would be things like elemental stability, diversity, and relative abundance. If I had a universe, for example, with only hydrogen, it's not very likely that we could form the necessary molecular structures to process energy, store information, and replicate, the minimum requirements for a living system. We need a universe in which we have long-term sources of usable energy, a source such as our own sun, which has provided over a very long period of time an almost constant rate of energy, changing only slightly with time over 5 billion years. The matching, next we need, for example, the matching of energy levels for chemical bonding with energy of photons of light. If in fact I'm going to foster the right kinds of chemical reactions for living systems with energy from the sun, then the bonding energy of the various chemical elements must be very similar to the energy of the photons which come from the sun. If the energy of the photons from the sun is much too energetic, as it might be, for example, with ultraviolet light, it would tend to destroy all of these compounds. If in fact it's too low in energy, in fact it won't foster the chemical reactions at all. So we've got to have a very careful matching of energy sources or energy of radiation from the sun with the kinds of elemental bonding that we have with our periodic chart. Well, there are many such requirements, approximately 77 others could be enumerated, but the important point is that having a universe with the right mathematical form does not get us home free. There are many other requirements that must be met, and these can be met at least in part if our universal constants are carefully selected. Mathematical form then is a necessary but not sufficient condition for a universe suitable to support life. The very specific values for the 19 universal constants are also required to meet the requirements previously stated in many others for a universe suitable to support life. I'll provide several short examples. Let's first of all look at what we mean by universal constants. If you've taken a high school or college science course, in the inside flap of your textbook, particularly a physics or chemistry book, would involve the listing of a whole series of terms and appropriate values, typically in MKS units. Things like the speed of light, 3 times 10 to the 8th meters per second, Planck's constant, Boltzmann's constant, the unit charge, the rest mass of the proton, electron, and neutron, the gravity force constant. Now, about 40 years ago, people began to ask the following questions. Why is the speed of light 3 times 10 to the 8th meters per second, and what difference does it make? Suppose the speed of light had been something quite different than that, 2 times 10 to the 8th meters per second, or maybe 4. What, if any, difference would it have made? Now, I think the assumption people made at the beginning of this exercise was if the speed of light were different, the universe would be slightly different, and life would assume an appropriate, incrementally different form. What has been the surprising outcome of this kind of parametric study using cosmological models is that small changes in almost any of the universal constants produce rather draconian changes in the character of the universe, rendering it unsuitable, not just for life as we know it, but for life of any imaginable type. Let me share with you several examples. The strong force is that force that binds together the protons and the neutrons in the nucleus. Were it not for the strong force, the Coulombic repulsion would cause nuclei to blow apart, and we would have no elements but hydrogen. The electromagnetic force would be, for example, in the nucleus, the Coulombic force of repulsion between the positively charged protons. If the ratio of the strong force to the electromagnetic force were increased by only 2%, we would have no stable hydrogen, therefore no long-lived stars, no hydrogen-containing compounds. On the other hand, if the ratio of the strong force to the electromagnetic force were only 5% less than it is, we would have no stable stars, heavy hydrogen would be unstable, there would be few if any elements besides hydrogen. Now, we do not need a universe identical to this universe to imagine life, but there are certain minimum requirements that would seem to be necessary for any universe to support life, things like, as I mentioned before, a long-term source of energy and a certain amount of elemental diversity. If, in fact, these two forces are not very, very carefully matched to each other, then we'll either have a universe with no long-term source of energy or a universe with no elemental diversity, either one being a universe unsuitable for life of any imaginable type. The problem is worse than what I've mentioned, though, because it's not enough just to get the right elements present. It's quite important that we get the right relative abundance of these various elements, and we'll talk a bit more in detail about that later. But this requires a much higher precision in the specification of the ratio of the strong force to the electromagnetic force than I previously noted, basically this narrow range here. As a second example, I want a sun that provides a long-term source of energy and energy with about the right radiation. right energy level. Okay? Energy sources depend on, such as the sun, depend on the relative magnitude of the gravity and the electromagnetic force or its associated constant. Now, it's interesting to note that the electromagnetic force is about 10 to the 36 times stronger than the gravity force. That's a huge difference. Let's try some other numbers. If the electromagnetic force were only 10 to the 30th time stronger than gravity, stars would burn 1 million times faster. They would provide a very different and inappropriate energy in their photons, and there would be no long-term source of energy for the Earth. As another example, we need to balance or match the energy, as I mentioned before, in light to the bonding energy in chemicals. The electronic energy levels and the chemical bonding energy levels that come from those are determined from quantum mechanics, and they depend on the mass of the electron, the unit charge, and Planck's constant, with an equation that looks something like this. Okay, bonding energy between these different atoms. The wavelength of light, if it's going to be tailored to the chemical bonding energies, would require a spectrum which has its highest intensity in what we call the visible spectrum. This visible spectrum, which in fact we have, requires satisfaction of the following algebraic equation. Now, don't let the equation intimidate you here. It's nothing more than algebra. This is an inequality sign. This is approximately equal to sign. The term on the left must be greater than, but of the same order of magnitude as the term on the right. And the constants in this equation are, in fact, Planck's constant, speed of light, gravity force constant, mass of the electron, mass of the proton, and the unit charge. Several of these were required in the previous requirement for specifying chemical bonding energy. If I take all of these values from the chart I showed you previously and substitute them into this equation, lo and behold, I get a result that looks like this. The left term is, in fact, bigger than the right term, but they are both of the same order of magnitude. And what this says is that the selection of these constants, in fact, is in exactly the right proportion to each other, as required by this equation, to allow the energy from the sun to be exactly right, to be interactive with chemical bonding in the periodic chart that we have. There are a couple of other interesting things that come out of this that are not specified in that preceding equation. If I'm going to have visible light as the primary source of energy to drive the necessary chemical reactions in living systems, then it's important that this radiation not be highly absorbed by the atmosphere or by water, because most of the important biochemistry occurs in a water or aqueous solution. If you look at the absorption as a function of wavelength of light, what we find is that almost all wavelengths of light are highly absorbed by water and by the atmosphere. Only in this very narrow range of visible to infrared is there very, very little absorption of that very same wavelength of radiation that's necessary to drive our chemical reactions. And the same thing, surprisingly enough, with our atmosphere. So it turns out not only is the energy of light, the primary wavelength of light from the sun, exactly what's needed for chemical reactions, it also happens to be very low in its absorption with water or with the atmosphere. If the light we needed or the radiation we needed was someplace either here or here, it would actually help chemical reactions, but it would never get to the chemicals because it would be highly absorbed. Commenting on this and many other similar kinds of requirements, Professor John Wheeler from Princeton University says slight variations in physical laws such as gravity or electromagnetism would make life impossible. The necessity to produce life lies at the center of the universe's whole machinery and design. Freeman Dyson says, as we look out into the universe and identify the many accidents of physics and astronomy that have worked to our benefit, it almost seems as if the universe must, in some sense, to have known that we were coming. Nobel laureate Arnold Penzias puts it this way: astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest an underlying, one might say, supernatural plan. Well, let's summarize this section on universal constants. There are approximately 80 conditions that must be just so for a universe to support life, not just as we know it, but life of any imaginable type. Things such as stable sources of energy, the proper elemental diversity, the matching of energy from the sun with chemical bonding, and not being absorbed by water or atmospheric conditions. It's quite remarkable that the 19 universal constants are in fact exactly what they must be to provide this truly unique universe where life may exist. Now, I should emphasize may because it's quite possible to have exactly the mathematical form that we have, to have the universal constants be just so, and still end up with a universe that doesn't provide any suitable habitat for life. The fact that we have the mathematical form and the universal constants is necessary, but not by itself sufficient to have a universe with a planet such as Earth. The requirements of the initial conditions are going to be also extremely demanding. If you remember from my illustration with the Leaning Tower of Pisa, we had the mathematical form that the falling balloon would follow. We had the universal constant, in that case, the gravitational force constant. Then we had some initial conditions. And it's those three things in combination that ultimately allow the purposeful outcome to be accomplished. Well, in our particular case, we're going to need initial conditions that are very special for a universe to have stars that provide sources of energy, such as the sun. The universe could easily have expanded at such a rapid rate that there would never have been any condensation of hydrogen into stars, or it could have expanded at such a slow initial rate that it expanded and recollapsed before the necessary conditions in the universe could develop to support life. We furthermore need initial conditions that provide not only a proper sun, but conditions that provide a planet in conjunction with that sun that meets the many special requirements to support life. Things like right distance from the sun to give the right climate, right mass to retain the right kind of atmosphere, etc. If you look at an automobile engine, there's nothing particularly supernatural about the operation of an automobile engine. A good mechanical engineer can explain the operation of every component in the automobile engine without any recourse to supernatural. Everything operates within the domain of natural laws. On the other hand, explaining the existence of the automobile engine requires something more than just the laws of nature. While each component part operates within those laws, the existence of this rather special configuration of components would never happen naturally in nature. Somebody had to design each of the component parts, somebody had to manufacture them, somebody had to assemble them, somebody has to maintain them. When all of this is done, chemistry and physics operates under rather special and extraordinary conditions. The net result of which is we convert chemical energy in gasoline into torque on the wheels of your car. Again, nothing supernatural about the operation of an automobile engine, but obviously intelligent design is an essential part of the explanation of how automobile engines come into being. By analogy, one can look at even some of the simplest living systems and say, gee, simplest living systems are not simple at all. They're actually relatively complicated. It's believed that the earliest living system, the origin of life, must have been something much simpler than this, but it can't be absolutely simple because it's got to be complicated enough to process energy, store information, and replicate. So we have this dilemma of how do we create these rather special initial conditions necessary to account for a suitable habitat for life and for life itself. If we look at different living systems, for example, we'll find that in fact, much like a schematic for an automobile, they require many different metabolic components that work in a rather sophisticated network, an interdependent network for function, and that many of these components are themselves quite complicated, such as the protein. This is a protein molecule which, if you were to stretch it out, would be about 100 building blocks joined together, folded into this much more complicated three-dimensional structure. And so living systems seem to have as their distinguishing or characteristic molecular components that are themselves very sophisticated, the origin of which is at this point still quite obscure. Well, let's look at these initial conditions and say what must be true beyond mathematical form being what it is, Universal constants being just so, still we have a high probability we end up with a universe that's just devoid of a suitable place for life and devoid of life itself. The initial velocity after the Big Bang, as I mentioned a minute ago, is extremely critical. The ratio of the gravity or potential energy to the kinetic energy must be equal to 1 part in 100,000, according to a recent article in Scientific American. The two components of the expansion driving the cosmological constant must cancel to 1 part in 10 to the 123rd. Very difficult to imagine how these kinds of initial conditions are going to happen in some accidental way. With regard to a suitable habitat for life, the previous conditions really are those necessary to produce stars. But producing stars by itself doesn't get us home free. We've got to have suitable planets around those. A fellow named Drake in 1962, working with Sagan, and then a more recent work by Sagan in 74, addressed the question, is life inevitable or is it remarkable? Now, what these two fellows suggested was that there are, in fact, many suitable homes in the universe, maybe as many as 1,000, possibly as many as 1,000,000. And if indeed this were so, then we would have to agree with Carl Sagan that life is not special at all. It's inevitable. It just happens. The universe is such that life is one of those sort of almost inevitable outcomes of simple natural causes. A more recent book in 1982 went back and re-examined with much more empirical data some of the assumptions that were used to make these predictions. Two astronomers from the University of Virginia, Rode and Trefel, and in the book they wrote, Are We Alone? In 1982, they determined that suitable homes in the universe are indeed, it should be rare, not rate. The probability of life anywhere is rare. Life is, in fact, quite improbable. Trefel, writing in the concluding chapter, says, if I were a religious man, I would say that everything we have learned about life in the past 20 years shows that we are unique and therefore special in God's sight. He goes on to say, I'm not a religious man, and therefore I believe that life in the universe is the result of a remarkable coincidence. And we need to be ecologically very careful, because if we destroy life here, we probably destroyed the only life that exists anywhere in the universe. In a more recent book, this is actually 2000, Peter Ward and Donald Brantley, who I accidentally left off of the marquee here, wrote a book entitled Rare Earth. And in this book, they argue that the Earth is a truly unique place in the universe. They're both professors at the University of Washington in Seattle. And the existence of such a home for life is truly remarkable. Well, Sagan's argument basically went like this. The chances in conjunction with any star of having a planet that meets all the necessary requirements is pretty low. But if you look out into the universe, there are a lot of stars, about 10 to the 24th. And if, in fact, there are that many stars, then one might logically intuit that some of these stars have to have planets that would be suitable homes, much like our own home on Earth. So this is basically through a very powerful telescope looking out into space and simply noting that, gee, there are lots of stars, and maybe it seems reasonable that some of these would provide homes suitable for life. Carl Sagan's, the movie based on Carl Sagan's novel, Contact, highlighted the search for extraterrestrial life based on what I think is Sagan's overly optimistic expectation of finding extraterrestrial intelligence. If, in fact, there are 1 million places out there in the universe where life exists, then the chances of us getting messages from outer space are indeed quite good. If, in fact, the chances are more like 1 in a billion, then maybe it's not the best way to spend our money. William Proxmire, reading the book Are We Alone in 1982, made the following comment: why are we spending so much money looking for intelligent messages from outer space when it's so hard to find signs of intelligence in Washington? Well, whether you're a Democrat or a Republican, we could probably be bipartisan in at least agreeing with this search for intelligence in Washington is a pretty dicey business. Well, this book, Rare Earth, which I mentioned a minute ago, Why Complex Life is Uncommon in the Universe, is a great book for addressing all of the different initial conditions that are required for living systems. Let me mention just a few of these. We don't have much time left. First of all, he says there are many places in any given galaxy which are going to be unsuitable for a star where a planet might have life. He says if you're in too close to the center of the galaxy, the problem you're going to have is that there are too many other nearby stars. There's supernovas, there's neutron stars, there's high-level X radiation. These things would all sterilize any planet that might otherwise be trying to develop life. So the argument goes, if you're in too close to the center, forget it. It's just too hostile an environment. On the other hand, if you're too far out, you're going to have another problem with elemental distribution. In fact, we need some heavy metal elements for reasons I'll mention shortly. These heavy metal elements are typically pretty rare out here. So if you're in too close, it's a hostile environment. If you're too far out, you don't get the right elemental diversity. In fact, the ideal place to be would be someplace between the spiral arms in a typical galaxy. And in fact, our galaxy finds itself exactly in such a location at a distance that is about a third of the way out, maybe halfway out from the center of our galaxy. So our star is well located in a position where there are not too many other nearby stars, therefore not likely to have sort of astronomical catastrophes that affect us because we're nearby, and not so far out that we can't get the required elements that we need. Another requirement has to do with the size of our sun. This is actually a drawing that shows the sun and the Earth drawn to scale. The distance between them is not to scale. The Earth would be much, much farther out. But the size of the sun ends up also being very important. It will determine the rate at which the sun burns. It determines the magnitude of the, or the energy of the photons that come out of it. It determines the length of time that it will be around. All of these factors being individually quite important. One of the interesting things that's been pointed out by Michael Denton, but I think it actually goes back to some other chemistry professors from Harvard earlier this century, is that there is a special range of temperatures that is necessary. As you look and say, what's the temperature range necessary for a suitable habitation for life? Obviously, it needs to be at least a part of the year between 0 and 100 degrees C. Why? If it's always above 100 degrees C, you're going to have no water. It's all going to turn to steam. If it were year-round less than 0 degrees, you'd have all ice. The chemistry of life seems to require a universal solvent, and no other liquid would come close to comparing to the properties of water to provide that. But water exists as water only in this relatively narrow temperature range. Now, not only does it happen that water has its liquid state between 0 and 100 degrees C, but it's been found that the primary bonding and the secondary bonding are most advantageous in a temperature range in which we have between 0 and 100 degrees. So for several different reasons, staying in this temperature range ends up being quite critical for weak bonding and for primary bonding. Now, if we look at a solar system in which the star produced half as much energy as our sun, there would be a region in which the temperature range was quite appropriate that would be in closer than either Venus or Earth. If we look at our star, in fact, there's a region where the temperature range is, in fact, inclusive of where Earth is. If we had a star that was 1.3 times brighter than our sun, in fact, the range where temperature would be appropriate is, in fact, much farther out. You can actually do some calculations and say if you're going to limit the temperature from 0 to 100 degrees, the range plus or minus here is about 10% of what the Earth's radius is. So there's a relatively narrow range. Now, for complicated animal life, we know we can only live within 0 and about 50 degrees C. And if you limit that, then the habitable range ends up being even much smaller. If we look more closely at the whole of our solar system, you can see where Mars is, you can see where Earth is, you can see where Jupiter is. There's a ring of other sort of astronomical debris. And in fact, the placement of our Earth in this very huge range of possibilities must be plus or minus between 5 and 10% of what, in fact, it's found to be. Otherwise, it's going to either be much too hot, such as Venus, or much too cold, such as Mars. And you can see there are lots of possibilities that aren't going to work at all. There are a whole host of other requirements, and I'd like to read just a couple of short quotations from this book, Rare Earth, before we bring this section to a conclusion. The author's writings say the following: if some godlike being could be given the opportunity to plan a sequence of events with the express goal of duplicating our Garden of Eden, the power would face a formidable task. With the best intentions, but limited by natural laws and materials, it's unlikely that Earth could ever be truly replicated. Too many processes in its formation involve sheer luck. Well, that's their interpretation. Earth-like planets could certainly be made, but each outcome would differ in critical ways. This is well illustrated by the fantastic variety of planets and satellites that are formed in our solar system. They all started with similar building materials, but the final products are vastly different from each other. Just as the more familiar evolution of animal life involves many evolutionary pathways with complex and seemingly random branch points, the physical events that led to the formation and evolution of the physical Earth also required an intricate set of nearly irreducible circumstances. Well, the whole story of the book is the many, many different things that must be satisfied to be just so. And there's about 250 pages of very, very interesting, and I should add, very accessible examples. Fred Hoyle, writing in his book, The Intelligent Universe in 1984, put it in the following way, talking about the universal constants being just so, talking about all of these initial conditions being somehow met, says the following: such properties seem to run through the fabric of the natural world like a thread of happy coincidences, but there are so many odd coincidences essential to life that some explanation seems required to account for them. Now, when I gave this talk at Iowa State a couple of years ago to about 1,000 students and faculty, a philosophy professor the next day wrote a rather nasty letter to the newspaper saying I had misrepresented Hoyle's views. I must have somehow quoted him out of context. And in his letter to the newspaper, he quoted the following: I've often seen it stated that our situation on the Earth is providential. This is Hoyle, he's quoting. The argument goes like this: it's providential that the Earth is of the right size and at the right distance from the sun. It's providential that the sun radiates the right kind of heat and light. It's providential that the right chemical substances occur on Earth. And a long list of this sort of statements could be compiled. And to some people, it looks as if there is indeed something very strange and odd about our particular home in the universe. But I think that this outlook arises from a misunderstanding of the situation, because if everything were not just right, we should not be here. We should be somewhere else, or more likely nowhere. Now, I think you'll agree that statement does seem to be just the opposite of the previous one. The logical question which this professor didn't ask was, when did Hoyle say what? This is a quotation from a book that Hoyle wrote in 1951. The quotation that I wrote was from Hoyle in 1984. What does this say? Between 1951 and 1984, Hoyle changed his mind. As the list of coincidences got longer and longer, Hoyle eventually said it's not reasonable to simply attribute these to coincidence. There has to be something more to the story than that. If I roll a dice once and get a 6, you're not surprised. I roll a dice 3 times and get a 6, you're not too surprised. I roll a dice 10 times in a row and get a 6, you begin to wonder. I roll the dice 100 times and get a 6, what do you begin to say? There's really something odd about the dice, okay? Give me a break. This can't be a normal dice. And in fact, as our list of coincidences about all the things that have to be just so in the universe has gotten longer and longer and longer, I think many scientists are no longer willing to quickly dismiss this as nothing more than fortuitous good luck. The term used, I might add, quite frequently in this book. Talking about the origin of life, which I think is probably the greatest enigma from an initial conditions point of view, Sir Francis Crick, in an article in Scientific American in 1991, quoted as saying, the origin of life appears to be almost a miracle, so many are the conditions which would have to have been satisfied to get it going. Harold Klein, writing for a committee of the National Academy of Sciences in 1990, says the simplest bacterium is so blankety blank complicated from the point of view of a chemist that it's almost impossible to imagine how it could have happened. Well, let's summarize this section with the following comment. An automobile does not violate any of the laws of nature, yet its existence cannot be explained by nature alone. The conditions under which the laws of nature operate are extremely special. If the chemical energy in gasoline is to be converted to torque on the wheels of your car. Such special conditions don't happen accidentally. They are the result of careful, intelligent design. And so it is with our home in the universe. Even with the mathematical form that nature takes, even with the universal constants being just so, it's almost inevitable that there would be no place like Earth that would be a suitable habitation for life. We would most likely see many, many other planets, such as the ones that we see in our solar system, and those only, which are nothing more than rocks or gaseous bodies circling the sun with no possible place for life to exist. Well, let's summarize our talk then with the following. Compelling evidence the universe began. Evidence the universe is precisely designed as in the beautiful mathematical form that nature takes. The remarkable coincidence that the 19 universal constants are just so. The amazing observation that so many different initial conditions are exactly right. In combination, argue persuasively that we do not live in an accidental universe, but one that was carefully crafted for our benefit. Going back to our original metaphor, what does the universe really look like? Does it look more like the design Ord in Hawaii, or does it in fact appear to be something more like Mount Rushmore? This slide's flipped over from the last one. Well, let me give you my answer to that question, and it looks like this. If you were to go home at Thanksgiving, and as you drove up into your driveway, you noticed that the trees had fall come in a rather unusual way in your yard. And in fact, if you look carefully, what you saw, much to your surprise, was a face and a hairdo that looked exactly like yours. What would you conclude? Gee, what an amazing accident that the leaves should fall off the trees in this way. No, I don't think that would be the most reasonable inference. You would probably assume what? A loving father, a mischievous brother, a very industrious boyfriend, somebody who's trying to honor you by plucking the leaves off the trees in this very, very special way. But it would hardly be reasonable to say, is it possible the leaves could have fallen off the tree in this way? The answer is yes. Is that the most likely explanation of what happens? I think not. And so it is, I think, with what we see to be true of the universe. Frederick Burnham, commenting on ABC's Nightline with Ted Koppel several years ago, said the following: the scientific community is prepared to consider the idea God created the universe a more respectable hypothesis today than at any time in the past 100 years. I think it's about 9:30, and the mind can only absorb what the sea can endure, and we may have already exceeded that limit for some of you who've stuck around nevertheless and been quite gracious. So let me thank you very much for your time and attention. It's been a pleasure to be here tonight to share with you. Now, as we conclude our presentation, I'd like to invite you to actively participate in the Q&A time that we're going to have shortly, and we welcome all questions, okay? Yeah, I think more than a question, it was a comment that some recent developments suggest maybe there aren't nearly as many stars as one might have assumed, because what we're seeing is something like a whole series of mirror images that would sort of multiply a smaller number of actual stars into the appearance of a larger number of star-like appearances. Don't know much about that particular article, though I'll certainly have to chase it down. But I would say that let's assume for the moment that the number of stars is in fact what has been conventionally thought to be the case, 10 to the 24th. Even if you go back as far as 1982, to the book Are We Alone, as people use more realistic estimates of the different requirements to have a star be a suitable habitat for life, or a planet in conjunction with a star, the requirements are such that even if you allow the large number of stars which Sagan assumed, and which I think then and maybe today is still thought to be the case, it's interesting as you go from 62 to 82 to 2000, the probability of life in conjunction with any star is dropping like a rock. And the net result is, even given the large number of stars where there might be a suitable planet, the probability that there is in fact one that meets all of the different necessary requirements is so incredibly small that the comments that I read in here are repeated about 15 times at different places, and they're using the it's almost impossible to imagine how all of these things could have happened maybe more than one time in one place. Okay? So I would say that even apart from having to say, gee, maybe this Sagan's argument was a bogus argument because the star estimate was too high, I would say let's concede there are 10 to the 24th stars. I think one still finds that the probability of meeting all the requirements, given that you can't be too far out, you can't be too close in, that knocks out many of the stars in any given galaxy. And then there are many other requirements within that. The book goes through a lot of different requirements. And when you see all of the things that have to be just so, it makes an automobile engine or a computer look like kind of a Mickey Mouse design compared to what's necessary to produce a suitable habitation for life. Yet no one would expect those to happen somehow on their own. Good comment, though. Other questions or comments? Yes, in the blue.
Could we?
Oh, okay. To get the questions on tape, we probably need to have you come down to the mic. So you're already at the mic. We'll let you be next, and he can be third.
I just want to thank you first for coming and speaking. I really appreciated it. Yeah. Oh, I'm sorry. My question is actually not one of my own. A friend of mine asked me, and I just wanted you to remark on the theory and maybe give your ideas on it, whether you've heard of it or not. It's actually the parallel universe theory, and he asked me to ask you about it to see if you had any ideas. So can you explain it maybe and then talk about it?
If by parallel universe you're talking about what has become fashionable in the last 10 years, an infinite number of alternative universes, I think that I get this question almost every place I go, and I think the reason is that it's been really in the last 10 years that the full force of the problem as I presented this evening has become appreciated. And I think most scientists are willing to concede that if this were indeed the only universe, then it seems almost inconceivable that everything could have come out just right. The alternative way to try to escape what would then be the implication of design, rather than some sort of natural accident, is to say, well, suppose, and suppose is the operative term here, there were an infinite number of alternative universes. Then even the improbable becomes probable if each of those can be thought of as having different universal constants, different initial conditions, and if you get enough rolls of the dice, sooner or later you get one in which everything is just right. Now, is that logically possible? The answer is yes. Is it scientifically supportable? The answer is no. We cannot observe things outside of the domain of our own universe. So if indeed there is an infinite number of alternative universes, or if there are an infinite number of alternative universes, there's no way we'll ever be able to verify that scientifically. And so it becomes, I believe, a metaphysical statement of faith, different than, but not unlike, the metaphysical statement of faith that says, based on what we see in the universe, it seems most reasonable to posit an intelligent designer. So I would say, is it possible there are an infinite number of alternative universes? Well, it's not impossible. Is it the most reasonable explanation? Well, I would go back to my tree in which the leaves fell off in a rather special way. I think it's probably much more reasonable to say that there appears to be an intelligent creator, and furthermore, the historical evidence for Christ, his life, his death, his resurrection, the existential claims of many people that they experience a personal relationship with God. There are many other what I think of as supporting evidences other than just the direct scientific evidence that would seem to make belief in an intelligent creator very plausible, and for my money, much more plausible than the infinite number of alternative universes. But as long as people are positing that, at least it says they really understand the problem, and they're responding in a way that maybe they feel more comfortable with metaphysically. But I don't think it should be confused with some alternative and superior scientific idea, which it really isn't. Okay.
Thank you.
Thanks. Yes, next question.
I was just wondering if what kind of time frame you put the universe in, billions of years, thousands of years, and whether or not you were a theistic evolutionist, straight-up creationist, what your feelings on that were.
And I don't think you gave me enough choices. What were my choices?
Well,
Theistic evolutionist
or straight up creationist or whatever your feelings might be on
straight
that.
up creationist. Okay, still don't think I have enough choices, but I'll answer your question. Okay,
You can create your own
I'm
choice.
giving you a hard time for no reason. If you want to give me a label, I'm a progressive creationist. I believe that God used a combination of miracle plus process to effect his creation. If I look at the action verbs that are used in Genesis 1, bara, typically translated create, everywhere in the Old Testament, and it's used infrequently, refers to God acting in some supernatural way. Bara, translated make in Genesis 1, other places in the Old Testament, it's used 1,900 times, almost always referring to process, even when it refers to God's activity, where it talks about God baras the rain to fall on the fields. Well, I think God does cause the rain to fall on the fields, but I think he does it in his customary way, as described by laws of nature, as expressed in astronomy, astrophysics, okay, or in atmospheric physics, not astrophysics. If you look at the Hebrew word yom, in the first several chapters of Genesis, it's usually translated day. But even in the Genesis account, it would be used at least 3 different ways if you read carefully. The accounts in Genesis 1 and the first 4 verses of Genesis 2. And I would recommend using a New American Standard translation. The Hebrew word yom is actually used in Genesis 2:4. In some translations, the term day doesn't appear, which is to say it's not a word-for-word translation. But I would argue that the Hebrew word there can refer to day as in 24-hour day or period of time. And it seems to me that to reconcile Genesis 1 with Genesis 2, not to mention to reconcile it with geology and astronomy and a bunch of other things, I think that to interpret the Genesis 1 yoms as periods of time other than 24-hour days is, I believe, probably a more accurate interpretation. I understand that y'all had on Saturday a speaker who talked about the framework interpretation, and I think that's obviously another interesting possibility. But I think trying to interpret them strictly as a literal 24-hour day, 1-week creation, I think creates internal problems in the Bible, not to mention problems trying to harmonize with what seem to be some of the observations of science. If you're interested in the details, I wrote about a 50-page paper for the International Council on Biblical Inerrancy in 1982, and you can find that at a website that's www.leaderu, and that's leaderu.com. If you click on faculty offices on the left side of the front page of the website, you'll find mine, and you'll find an article there which gives you a long-winded answer for what I've given a very abbreviated one, okay? Yeah. Next. Good, we need a lady question. We haven't had any lady questions
Thanks.
yet. Okay.
I was just wondering, this follows with that question, what your opinion would be on the design of human beings, and if it's a evolutionary view, then how you would interpret the story of Adam and Eve to fit into that timeline.
Okay, now let me clarify my previous answer because your question implies I didn't give a clear answer. When I say I'm a progressive creationist, that's different than a theistic evolutionist, okay? I'm arguing that God used a combination of miracle plus process, and I certainly would agree that if there's one part of Genesis 1 that I think needs to be taken literally, it's a historical Adam and Eve. And I think that's important for theological reasons, quite apart from any scientific implications. The fall of Adam and Eve is a very important theme that reoccurs throughout the Bible, and I have a hard time imagining that a figurative Adam and Eve could provide a literal fall that seems to have implications for the human race and really for the mess that the world's in today. And I think the world is as God intended for it to be. It's a world that's degenerate because of the fall and the consequences of that. So I would certainly say that I believe in a literal historical Adam and Eve. The fact that the universe is quite old does not necessarily mean that Adam and Eve have to be quite old. Adam and Eve come at the end of the story, right? And so one can certainly allow for a much older universe, which I think is not inconsistent with the biblical story, and yet at the same time continue to affirm a real, literal historical Adam and Eve.
Okay, thank you.
Sure. Yeah. Okay. Next question.
Okay, well, I'm probably about to make a fool out of myself, but it's something that I'm really interested in. I don't really belong to any sort of form of religion or anything, any system of belief.
Okay.
I'm just kind of exploring it for myself, and I'm kind of leaning more towards like the Eastern philosophies, mainly like Buddhism and Hinduism, and more in terms of circular sort of life. Um, and I was just wondering I don't know, you said that in your college days you explored the different world religions, and I was wondering what your view on that stuff was.
Now, if you, by circular, mean some belief in reincarnation, then I think that would probably be more consistent with Hinduism. I don't think Buddhism has several different sects, but I'm not sure the general belief in Buddhism really believes in an afterlife or a reincarnation. Hinduism believes that. But the thing that I would recommend for you to look at, if you're interested in a more careful comparison of the different religious claims, if you go to www.leaderu.com, they actually have, and that's Leaderu, not Y-O-U, but leaderu.com. And if you look under world religions, they have a wonderful chart that has about 15 different important theological questions, and then the answers that each of these world religions give to those questions. So in one place, you can really at least get what I think of as the important comparison of what do these teach about what God's like, what does it teach about the nature of man, what does it teach about the possibility of a relationship with God if in fact the religion believes in a God. Some versions of Buddhism don't believe in a personal God in the way that Christianity does. And so it will give you a lot of information. A book I would highly recommend, and it's not lengthy, it's about 100 pages, is a book called Truth and Religion. And the author is a fellow named Mortimer Adler. That name sounds a bit familiar. He's written about 45 different books on philosophy. He was the founder of the Aspen Humanist Institute. He was the editor of the Encyclopedia Britannica. He taught at the University of Chicago. And in this particular book, he tries to point out that in our modern desire to have a pluralistic society in which everybody accepts alternative beliefs, the problem with doing that when it comes to religion is if all religious truth claims are valid, then they must all be trivial because there are too many that are contradictory. And if we're going to have truth in religion, like truth in mathematics and science, then we need to be able to evaluate these truth claims using the law of non-contradiction, and at certain points where it intersects history or science, to be able to try to validate it with what we can know from history and science. And so the whole point of the book then is to try to say which, if any, of these religions might have real truth about God and how we can relate to God. And I would highly recommend it for your consideration. At the time Mortimer Adler wrote the book, he was an agnostic. So he was really writing with no axe to grind. He wasn't trying to sort of favor one religion over the other. I think he was on a personal journey to try to decide what he was ultimately going to believe. Mortimer Adler, his A-D-L-E-R, Mortimer, it's a good Jewish name, M-O-R-T-I-M-E-R, Mortimer Adler, A-D-L-E-R, and the title of the book is Truth in Religion. Your library here will almost surely have it. It's a fairly well-known book. It was written in 1992. And at the end of the book, he comes to the conclusion there are three world religions that might be true, and those three are Judaism, Islam, and Christianity. And he says that's as far as you can go using the tools of a philosopher to decide which of these three, if any, might be true. One needs to look at historical and other kinds of evidence, other ways of knowing. If you look at those three world religions, they have a common ancestor in Abraham and Sarah. They have similar moral teachings, but they differ dramatically in terms of the theology and how we come to God, and particularly on who Christ was. So the question of who Christ is then, I think, becomes probably the critical religious question for a person who's seeking God. If, in fact, Christ is who he claimed to be, God stepping into history, then that trumps all other claims for me. If indeed that's not so, then we've got a bunch of other religious claims by people who didn't necessarily claim to be God, but claim to be religious leaders of one sort or another. And one's got to try to decide then which of those might in fact be valid. Okay? But I think the question of who Christ is probably the single most interesting question, because if indeed that happens to be so, then it, I think, certainly means that the truth claims of Christianity, at the place where they contradict truth claims of other religions, I think have to supersede those. As we look at various different religious truth claims, it's fair to say that all the religions share certain claims in common, and so in some sense we can say all religions embody some truth. But there is a certain place where the claims become quite contradictory, and at that point then we either have to decide this one's true or that one's true, or maybe they're both false, but they can't both be true. And Mortimer Adler's book is really quite insightful, I think, for helping you to think through that very carefully and looking at some of the different religious truth claims. But I hope those sources are helpful to you, and if you'll indicate on your comment card your interest in this, I'm sure that some of the local sponsors can also help you with other resources that you would find interesting here. A book I would recommend on Christ truth claims is a book called The Case for Christ by Lee Strobel. The Case for Christ by Lee Strobel, S-T-R-O-B-E-L. He's a lawyer and a journalist who was a reporter for the Chicago Tribune, who spent 2 years doing what is really an investigative reporting exercise, trying to find out, as an agnostic, who really was Jesus Christ, and talking to experts in many different areas, and finally coming to the conclusion that using the tools of an investigative reporter and a lawyer, that Christ was exactly who he claimed to be, and through that becoming himself a Christian. So, but that would be at least one book. I'm sure some of the local people here can suggest others as well. If you play your cards right, they might even give you one. So make a note on your card you'd be interested if they're handing out literature of this type, which I suspect they might be. So yeah, indicate that on your card. Be sure and tell them how to get in touch with you, okay? Yeah, other questions?
I had a little personal question about how you go about research as a man of science. You said a couple times mentioning reconciling Scripture and what science seems to claim, and I was wondering what you took as most important or what supersedes the other when you're confronted with an issue that doesn't seem to match. Do you take the Scripture and see if there's a way it fits with science, or take the current science belief and try and reconcile that with Scripture?
This sounds like a trick question. Is this a trick question?
No, just curious.
Let me say, first of all, that I definitely believe in biblical inerrancy. Okay? The problem is never with the inerrant Scripture. The problem may sometimes be with my uncertain interpretation of that. Okay? I believe God's the author of creation, and God's the author of the Bible. If I properly understand both, I should have no problems. Where I do have problems, it's obviously my interpretation of Scripture or my interpretation of natural data in some inappropriate way. I certainly would agree with the hint in your question that the Bible should be a higher authority. There's no doubt in my mind that that's what God intended. On the other hand, I always want to be cautious that I don't elevate my interpretation of maybe some ambiguous passage to that higher plateau, which makes it untouchable with regard to physical data. I think as far back as Augustine, major Christian theologians through the centuries have always indicated that we certainly should be prepared where there are clear findings of fact, not speculation, in nature that would call into question my interpretation of Scripture, that I be willing to do that. That's not to say that science is higher than Scripture. It's to say that there are places where maybe my interpretation of Scripture can be appropriately informed by science. And probably the classic example of A place where that was appropriate was the teachings of the Catholic Church that the earth is the center of the universe. And there are certain verses which, taken at face value, might imply that, but they were verses that were speaking as we normally experience things. Our weather reporters every evening say what? Sunrise and sunset. But they're not making stupid astronomical claims. What they're really doing is speaking about things as we experience them. And there's certainly places in the Bible where that's done. If I take a passage like that and try to infer from that scientific data, I make a big mistake. And I think the church has made at least a few of those in the past, and should be appropriately then cautious about being dogmatic about things where science seems to show clearly something, and maybe my interpretation of some verses of Scripture would seem to give a contrary indication.
Thank you.
Sure. Okay. Were you going to ask a question?
Just what exactly you think of inflation theory? Because I know that the idea that that in terms of how the universe originally expanded, and in terms of how that applies to different laws of physics, and wouldn't that simplify it even simplify these laws of physics even further to say that there's something even higher on the hierarchy controlling them? Like,
yeah, in fact, I had a chance at a meeting about 2 weeks ago to talk to Alan Guth, who first formulated inflation theory. I think the main thing inflation theory does is it helps to get around some huge initial condition problems having to do with the initial velocity. The requirements of the initial velocity have to be accurate to 1 part in 10 to the 60th, and that seems impossible. Nobody believes you could be that lucky. Inflationary theory, I think, is formulated to try to show a way that maybe that could happen and make the outcome more deterministic rather than probabilistic, okay, or accidental. It doesn't solve any of the other problems that we talked about tonight. It simply solves that one initial velocity problem. And I don't think the inflationary theory, as I talked to Dr. Guth, who's a professor at MIT, he was asking me about universal constants and other sort of fine-tuning arguments, because in his own mind, I don't think he believed that inflationary theory resolves what I think of as the fine-tuning issues that have to do with the origin of the universe and having it have the right properties. It does, I think, very nicely solve one critical initial condition question.